This is a second example of 4 questions from chapter 6.3 on multiplying fractions together. The first question says, what's the equation? And if I was to take away these red lines, let's move them down for a second. Take away those red lines for a second. The fraction that we started with was a third. Okay, we started with a third. And if I put those red lines back in place, how much did I keep of the third? Well, I cut it into quarters with those red lines. I took that third and I made 3/4 of the 1/3 that I started with. Not 1/3 times 3/4, but 1/3 of, or sorry, 3/4 of 1/3. And since we all know that of means multiplication, the expression that I started with is 3/4 times a third, not 1/3 times 3/4. If you had 1/3 times 3/4, it's wrong. You have to ask yourself, what fraction did I start with? And that one was a third. How much am I keeping of that third? The answer is I'm keeping 3/4 of the 1/3, which means it's 3/4 times 1/3. And if I think about it, it used to be cut into 3 parts, and now, I'll use my blue here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12. It's now 12 parts. And the number of parts I get to keep, I get that one, I get that one, and I get that one. I get 3 parts out of the 12 contain chocolate or contain pizza or contain whatever I want. So the answer is 3/12. However, 3/12 is not lowest terms because both the numerator and denominator are divisible by 3, which means my final answer in lowest terms is 1/4. Okay? Your second question gives you the actual expression itself and says draw it and solve it. So if I change this multiplication symbol to the word of, and I read that as 2/3 of a half, then I know my starting fraction is going to be a half. And I'm going to draw a half to start. Now, how much of that half do I get to keep? Well, according to what I wrote, I get to keep 2/3 of that half. So I'm going to cut it into thirds, and I'm going to put 2 check marks. 1/3, 2/3. 2/3 of a half. So what used to be a denominator of 2 is now a denominator of 1, 2, 3, 4, 5, 6. And I get to keep 2 parts out of the 6, which is your answer. However, it's not lowest terms. Lowest terms for 2/6 would be 1/3 because both the numerator and denominator are divisible by 2. Question number 3 says, solve however thou wishest. Now, what could you do? Well, based on the last 2 questions, you certainly could draw it, and that's fine. You could draw 5/8 and take 1/4 of it. However, what we learned last day is when you were multiplying, and I think I'll drag this over here for a second. When you were multiplying, the secret is you can get the right answer by simply multiplying your numerators and multiplying your denominators. So instead of actually drawing it and thinking about what is 1/4 of 5/8, what does that look like? Well, if I start with 5/8 and take 1/4 of it, blah, blah, blah. Just multiply your numerators to get 5. Multiply your denominators to get 32. And that is your answer, 5/32. Now, what I want to remind everybody in this room is this, is that I don't want you to get just how do I get the answer, right? If I tell you that when you multiply 2 fractions together, just multiply the numerators, multiply the denominators, and that's your answer, you have no idea what it means unless you can contextualize it with a picture or you can contextualize it with a sentence, right? Those 2 things I just circled, being able to draw it to understand it or being able to translate it into the word of, those are important things to remember because if all you remember is how you get the answer, it's not going to help you in the end. You're never going to be able to apply it to something, okay? And your last question says 20/27 multiplied by 9/40. Now, the reason why I gave you this question is because I also told you that when you are multiplying fractions, and it only applies for multiplication fractions, not for addition, subtraction, or division, but when you are multiplying fractions, you can multiply the numerators, multiply the denominators, and reduce it to lowest terms after, or you can reduce the fractions that you start with by cross-reducing. And I'm going to do it without cross-reduction first. So I'm going to multiply my numerators 20 times 9, over 27 times 40. I'm going to get 180 over 1,000. What is it? 1,080? 1,000. Is that what it is? 1,080? Yeah. 1,080. Now, this is the correct answer, but of course, teachers want you to be able to reduce it to lowest terms. So now we have to know our divisibility rules. So when both of those numbers end in 0, which means that both of those numbers are divisible by what number? What's the greatest number they're divisible by? 10. So if you know your divisibility rules, if you remember them from grade 7, you remember that if you have a numbers that end in 0, you can divide it by 10. That will be 18 over 108. Now I have to ask myself, what number is divisible into 18 and to 108? So right off the bat, we know that 2 is, right? Because it ends in an even number. But is there other numbers that are also divisible into those? And then we have to know our divisibility by 3. And divisibility by 3, if I take the number 18 and I take its digits and add them together, if the sum of the digits is equal to a number that's a multiple of 3, then the number itself is divisible by 3. So 18 is divisible by 3. If I take 108 and add those digits together, 1 plus 0 plus 8, I get a multiple of 3 as well. So 18 and 108 are divisible by 2, and they're also divisible by 3. And then I pause for a second and go back into the recesses of my mind and say, what's the divisibility rule if it's divisible by 2 and 3? What number is divisible by 6? So a number is divisible by 6 if it's divisible by 2 and 3. So now I know it's divisible by 2 and 3. So 6 is probably the most I know. But then I think to myself, hold on, what was the rule for 9? And then I think, hold on, I think it's like 3 but different. If the sum of the digits add up to a number that's a multiple of 9, then the number is divisible by 9. And that would mean that both 18 and 108 are divisible by 9 as well. So with all that said, I'm not even going to do any of those rules because I'm going to say, you know what, I don't know my rules. I'm just going to divide it by 2. I'm going to get 9 over 54. Then I'm going to say, hold on, I get divided by 3. I get 3 over 9. Oh, I can divide by 3 again. I got an answer of 1 over 3 is my final answer. Did I make a mistake? Oh, well, maybe I made a mistake somewhere. Yes, I did, because 54 divided by 3 is not 9. It's 18, which I would divide by 3, and I get 1 over 6 is your final answer. Correct. But look how much reduction I had to do to get that final answer. I had to get 1 over 6. So what we learned is this. And I'm going to erase all of this. I'm going to put my final answer over in the corner here just to remind ourselves there's the answer, 1 over 6. To remind myself that that's the answer. And what we learned was that when we multiply the numerators and denominators, I get 180 at the top and I get 1080 in the bottom. But if I was to swap those numerators, so take the 20 that's over here and put it over here instead. And take the 9 that was over there and put it here. If I was to swap the numerators, does it change this answer? No, it does not change the answer, right? So by swapping the numerators, it does not change the product, but here's what I can do. If I was to start with this question, 9 over 27 times 20 over 40, the difference between the original question and this one is I would probably reduce the starting fractions to lowest terms to start because they'd be smaller numbers, but they're still the same value. So instead of doing 20 over 40, I would say, hang on a second, I can reduce this down to lowest terms. I can divide both by 20. And what would 20 over 40 reduce to lowest terms? It would be 1 over 2. Agreed? And 9 over 27, both are divisible by 9. And that in lowest terms would be 1 over 3. So now look, I have a 1 in my numerator, I have a 1 in my numerator. If I multiply those two, I get 1. I now have a 3 in my denominator and a 2 in my denominator. If I multiply those out, I get 6. My answer, if I swap the numerators and reduce the starting fractions, my answer is the same answer I got in lowest terms when I reduced the original one down. But the difference was I didn't reduce my answer, I reduced my starting fractions. So if I go back in time, oh, that's not back in time. to here. Here's where we started at. So remember we swapped the numerators, it didn't affect the product, correct? I am not going to physically swap the denominator or numerators, but I am going to think that I did. So I'm going to pretend this 20 and this 40 were a fraction, because I know that that's what I thought of. I'm going to pretend the 20 and the 40 were over each other. What will 20 over 40 reduce to in lowest terms? We already did it. It's going to be 1 over 2, because both are divisible by 20. So I'm going to change the 20 to a 1 and the 40 to a 2. 20 over 40 reduces down to lowest terms as 1 over 2. What about 9 over 27? What's that reduced down to? 1 over 3. So now, instead of having 20 and 9 as my numerators are now 1 and 1. Instead of having 27 and 40 as my denominators, I now have 3 and 2. When I multiply those out, I get my final answer of 1/6 a lot easier than if I had to reduce 180 over 1080 to lowest terms by using division. Both work, don't they? One way I think is a little bit faster, a little bit more efficient. The other way works too, but this way is a lot easier, I think. Okay?